Hello, everyone. My name is Joseph Isaac, and this is the Capstone project for the Advanced Data Science with IBM in Coursera. And my project is going to be on sign language prediction using CNN. Let's get to it. As an introduction to the use case, the problem that I'm working with is using image classification, where I'm actually trying to classify images which is based on the American Sign Language. And the problem here is that sign language in it of itself is a visual language that uses a combination of hand gestures, facial expressions, and different body movements to convey the meaning. And of that sign language, there are two very commonly used sign language, which is the American Sign Language and the British Sign Language. Um, Sign language of itself need not be used when there is no need for any audio or if the person cannot speak. It is also in cases where the environment does not enable them to speak, such as loud scenarios where in the construction, when you are talking with the other person, they can't hear you, so instead you use sign language. And in quiet environments like libraries, where if they talk, you shouldn't talk. So you have to use sign language instead. And this is the stakeholders version of it, where I'm just giving it in the layman terms, and then later on, I'll be moving to the data science version. So this is the introduction for the stakeholders. So the problem statement here is that sign language has a lack of access for information and communication. Even sign language is commonly used. Not many people have the knowledge on how to do sign language. Basic things can be probably learned through experience in using some sign languages, but the actual knowledge like A, B, C, D, all the collective verbs and movements is not generally known to the public for sign language unless they are hearing impaired or having a hearing disability. So there's also a lack of accessibility in public areas. So in public areas, like I said, in libraries or in instructions or things like that, there's not many people who is having knowledge on sign language and how to use sign language for their communications. So many struggle to communicate with others who do not understand sign language. So if there's a person with hearing disability or someone who is using sign language, the person who they're sharing it with do not know that sign language. So that's an issue that's going on there. So there's a need for innovative solutions to improve this communication gap and the accessibility for sign language and the knowledge of sign language. So that is our particular problem statement. And our solution for this problem statement is using a sign language classifier. So basically what the sign language classifier does is it uses machine learning, a general form. We use machine learning to actually train a model to predict what is the sign they're showing, what is the meaning that they're showing based upon the sign languages that they're performing. And we're able to predict languages in near real time. That's our expectation, where we will build a kind of a classifier that when used, it'll be a video recording feature, and they'll take a video of the person who's performing the sign language, and pretty much like in a Google Translate, when you talk and then it reflects back, when they're doing a sign language, it should reflect back in the form of a sentence saying that this person is doing so and so things with the sign language. So it can benefit many people, as this sign language is a universal language. So if you are doing a sign language in one form and then they want to know the meaning in some other language, like let's say in French or German, we could of course just translate the meaning that it's being conveyed to a German text or the French text and things like that. So in generic flow, we're having the sign which is being shown. That will be passed on to the sign language classifier, which will then show what is the letter that's being set. So in this case, it's the letter A. So that would be concluding like, okay, we have the problem, we have the introduction, we have the problem, and then we have the solution in the stakeholders version. Now coming to the data science peers version, where we're going to be explaining more about the implementation. Here we go. This is the details of the implementation, where the classifier that we are using is going to be the convolutional neural network based classifier. And because I have picked this particular classification method, as it's an image-based classifier and convolutional neural networks works very well for images. So it's a good image-based classification. And as for the activation functions in the classifier, we are using the ReLU, which is the rectified linear unit. The reason for that is because in a convolutional neural network, the rectified linear unit is usually the way to go because it can train pretty well, it converges well, and you won't have the issues like stagnant weights or those kind of gradient related issues when you're using rectified linear units. So it's effective for CNNs. The next one is that we're going to use the categorical cross entropy for the loss function. This is because we are actually predicting 24 letters. The reason we're not predicting J or Z is that it requires a movement. So like something like this, those kind of movements is currently not being implemented. We're doing just static images. And since it's kind of a classification where we have 24 different letters, 24 different pictures, to have a loss function that deals with classification of multi-class classification, categorical cross entropy is usually the way to go. And as for the optimization, we're using the Atom optimizer. Reason being, the Atom optimizer is very effective. It's proven is worth when we're using it for CNNs. And the next best is SGD, but when we tried with Atom optimizer, it made better results. And as for the regularization, we're using the L2 regularization. We have tried with and without, and we actually see that when using the L2 regularization, it performs much better. So as for the data assessment, we are using the Kaggle dataset, which is the sign language MNIST. It's kind of like an MNIST dataset, but in this case, we're using the sign languages from the hands. And it has 24,455 training data with 7,000 and odd test data. And their size is 28 cross 28, black and white pictures, and their corresponding labels is given for the label data. And we're using the American Sign Language. And in this case, we're using the pixel value as the input for the CNN. And hence, for normalization, we have normalized that pixel value by its maximum, which is 255. So it's every value in that data is ranging from 0 to 1, which is very good for classification methods, or it's very good for your data science and machine learning in general to have lesser values when trying to predict models. As for the labels are one-hot encoded, and we're using a softmax layer in the ending for predicting the probability of the last label. So if it's like a 24 letters, we're having the probability like which letter is actually the most probable letter in this case. So as for the evaluation results, we're having two forms of models where one is with regularization, one is without regularization. I've tested in both cases where without regularization, of course, the training curve is pretty smooth and we're getting an accuracy of 90%, it was like 89.99 something. And so it's got rounded up to 90% in the test data. And with regularization, it was a bit jagged during the training phase, but the overall test accuracy was actually increased to 92.6%. So using regularization was very useful and it actually improved the model results. So in conclusion, we have implemented the sign image classifier using the American Sign Language using dataset from Kaggle. And we have used the CNN and have better results with regularization as compared to without regularization. And I've now performed the presentations to the stakeholders. The starting part was the presentation to the stakeholder, and the remaining part was the presentation for data science peers. So thank you for listening, and if you have questions, let me know. Thank you very much.